Yes, good morning, class. So today we are going to see the chapter polymers. Okay, so what is polymers? So polymer is a word which is coined from two Greek words. Okay, poly, what do you mean by word poly? Poly means many and mer means unit or a part. Okay, so polymer, it is a Greek word which is taken from two Greek words, that is poly means many and mer means unit or part. Okay, so the term polymer, what it defines as a large molecules which are having high molecular mass. Okay, so it defines the large molecules which is having higher molecular mass and higher molecular mass. So higher molecular mass or large molecule is also called as what? They are called as macromolecules. Macro means what? Large molecules. Okay. So how these are formed? So poly means what? They are formed. So these are large molecules. So how these large molecules are formed? These large molecules are formed by joining of repeating functional units. Okay. So small units, they make up a large molecule. So it is formed from a simple small unit. Okay. So this repeating structure, what will happen? It keeps on reacting. Okay. It keeps on reacting, or they have some simple and they have some reactive side. Okay. So the simple units, they keep on getting reactive. Okay, so these are reactive, these are simple and they are very reactive, and these small units are called as monomers. Okay, how these monomers are linked? So one monomer is linked to another by a covalent bonds. Okay, so this process of formation of polymers, okay, from this small unit, that is monomer, is called as polymerization. Okay, so we'll see what is the classification of polymers. Okay, so we understood what is polymers. So now we'll go into the classification of polymers. So first is based on origin or source. Okay, first is what? Based upon the origin or source. So first is the natural polymers. Okay, first is what? First is natural polymers. So natural polymers is what? They are obtained from natural source. Okay, so what is the natural source? That is plants, animals. Okay, so these are the natural source from where you can obtain your uh, natural polymers. Okay, so these are called as biopolymers. So these are also called as what? These are called as biopolymers. So what are the examples? Proteins, rubber, starch, cellulose. Okay, so these are all the sources. These are natural sources of polymers. Okay, these are the examples. So what are the sources? From plants and animals you get your polymers. So these are the examples. So proteins, rubber, starch, cellulose. So these are all natural polymers. Okay, so next is synthetic polymers. What do you mean by synthetic polymers? Man-made. Okay, man-made polymers are called as synthetic polymers. So these are prepared where? These are prepared in laboratory. How they are prepared? In laboratory by some chemical reactions. Okay, so by carrying out some certain chemical reactions, so these are prepared in laboratory. So what are the example? Polythene, nylon, PVC, okay, polyvinyl chloride, bakelite, etc. So these are some of the examples of synthetic polymers. What do you mean by synthetic polymers? Man-made polymers. Okay. Next is semi-synthetic polymers. So what do you mean by semi-synthetic polymers? Semi-synthetic. Okay, that means what? So these are derived from nature. Okay, these are derived from nature, but they undergo some chemical reaction. Okay, or they undergo some chemical process to enhance their quality. So the whatever the source from which you are getting this polymer, so it does not have so much polymer quality. Okay, so what it is done, so it is derived from nature. Okay, such semi-synthetic polymers, these are derived from nature, but they undergo certain chemical processes, okay, to enhance their quality. What is the example? Nitrocellulose, cellulose acetate, etc. Okay, so these are some of the this, okay, semi-synthetic polymers examples. So these are the three types of based on the nature or origin. Okay, so next we'll see based on structure. So how based on structure these polymers are classified. So first is your linear polymer. Now, what do you mean by linear polymer? The small units. Okay, so when the small units, what happens to small units? When the small units are linked in a straight line. Okay, when the small units are linked in a straight line, then it is called as linear polymers. So the small units, repeating units, when they are linked in a straight line, then it is linear polymer. What is the example? Polythene, nylon, etc. Okay, now these are linear polymers are high density okay, linear are high density polythene, okay, PVC, etc. So these are some of the examples of linear polymers. Now what do you mean by branch chain polymer? So there are presence of some branches. Okay, so there is a linear chain, to that some branches are present of polymers. So example is what? Low density polythene, okay, LDP, and starch, etc. So branch chain polymers, by the name itself you can understand. So there are some branches. Okay, so branch chain polymer. Then next is what? Cross-link polymer. What do you mean by cross-link? So in between the polymers, so there is a cross linkage. Okay, so between the polymer there is cross linkage. So when two monomers or monomers are formed by cross link, okay, then they are called as what? Cross-linked polymer. So the example is what? Bakelite. Okay, bakelite is an example for cross-linked polymer. So you need to remember the examples. Okay, so you need to remember the example based on the classification. So these are the three types based on structure. So we go to the next. So next is on the type of this, what? On the based on the type of monomer. Okay, based on the type of monomer. So first is homopolymers. So first is what? First is homopolymers. What do you mean by homopolymers? It has only one type of monomer units. Homo means what? Only one type of monomer unit is present. Okay, homopolymers. Then example is what? Polythene, PVC, Teflon, etc. Okay, so these are some of the examples for homopolymers. Homo meaning only one type of monomer unit. So this one type of monomer unit only keeps on repeating to form your what? To form your to form your homopolymer. Okay, homopolymer, polythene, PVC, Teflon. Keep the you have to remember the examples. Okay, you have to remember the examples for this classification. Yes. Then next is copolymer. Okay, so these are made up of two or more types. So it is made up of two or more types of monomer units. So if the polymer is made up of two or more types of monomer unit, then it is said to be copolymer. Okay, so example is nylon 6. Okay, then Buna S. So nylon 6. Then so it is okay. Then it is next is what? Buna S. So then next is polyesters. Okay, bakelite, etc. So these are some of the examples of what? These are examples of this copolymers. Okay. So next is based on mode of synthesis or polymerization. So based on the mode of synthesis of polymerization. So first is what? Addition polymers. So what do you mean by addition polymers? So these are formed by simply adding the different monomers. So small units of monomers, they keep on adding. Okay, so, simply they add up to form your addition polymers. So these are called as what? These are also called as chain growth. Okay, chain growth polymers. So what are the examples? Polythene, PVC, Teflon, polystyrene, etc. Okay, so these are the examples for addition polymers. So how they are found? They are found by simply adding the different monomers. Okay, they are found by simply adding the different monomers. So what is the other name? Chain growth polymers. Okay, remember this. What are the examples? Polythene, PVC, polyvinyl chloride, Teflon, polystyrene. Okay. So polythene is made up of what? It is made up of ethene. Ethene is the monomer unit. PVC, vinyl chloride. Okay. Vinyl chloride is the monomer unit. Okay. Then your polystyrene. Polystyrene is made up of what? It is styrene. So next is what? Condensation, polymerization. What do you mean by condensation, polymerization? So these are found by condensation of monomers with the elimination of small molecules. So what happened? Condensation. So when two monomers, okay, so two monomers, they want to get condensed. Okay, they want to get condensed. So what happens? So there will be some elimination of small molecules. Okay, so in this type of polymerization, what happens during the condensation of monomers? They result into elimination of some small molecules like water, ammonia, okay, etc. So these are also called as what? Step growth polymers. Okay, what they are called as? Step growth polymers. Okay, so this is condensation, polymerization. So condensation of monomers with the elimination of small molecules like water, NH3, etc. So these are called as what? Step growth polymers. What is the examples? Nylon 66, okay. Then bakelite, nylon 6 bakelite. Then bakelite monomers are what? Phenol and formaldehyde. Then terylene monomers are terephthalic acid and ethylene glycol. So you can see the monomers, two monomers are different with the elimination of small molecules. Okay, so these are the examples for your condensation polymers. Next, so classification based on molecular forces. So next we'll see classification based on molecular forces. Okay, so what is the classification? So first is elastomers. Okay, first is elastomers. So these are the polymers having weak intermolecular forces of attraction between polymer chain. Okay, so they are having, so these are the polymers are made up of very weak intermolecular forces of attraction between the polymer chain. Okay, so these elastomers, they possess what? They possess elastic character. Okay, so they are having very weak intermolecular forces. Okay, and they are having some elastic character. So what happens because of this? This elastic character, they can be stretched. Okay, they can be stretched from the original shape, and if you leave them again, they regain their original position. So because of the elastic character, these elastomers, if you are stretching it, okay, it can be stretched or it can regain their original shape. Okay, so these are elastomers. So what is the example? Natural rubber. Okay, natural rubber is an example. Then next is vulcanized rubber. Okay, vulcanized rubber. What do you mean by vulcanized rubber? What do you mean by vulcanized rubber? Your rubber, okay, your rubber is heated with sulfur. Okay, it is heated with sulfur, so it is called as vulcanized rubber. Okay, so we'll see it later. So next is what? Buna S. Okay, next is Buna S. So these are some of the examples of elastomers. So next we'll go to fibers. Okay, next is fibers. So these are polymers which have bit strong intermolecular forces such as hydrogen bonding. Okay, so these polymers in fibers, so they have strong forces like hydrogen bonding. For example, in nylon. Okay, in nylon they have such a strong hydrogen bonding. Okay, nylon 6,6, nylon 6. Okay, and they are having what? They are having high tensile strength. Okay, they are having high tensile strength. Why they are having high tensile strength means, okay, they are having high strength. So why? Because of the strong intermolecular forces. Okay, and as elastomers, they have high elasticity. These are having less elasticity. So fibers are having less elasticity. So due to strong intermolecular forces, fibers have high tensile strength and least elasticity. Okay. So next is thermoplastics. Now, in thermoplastics, what happens? So there are intermolecular forces in between those of elastomers and fibers. So we have seen in elastomers, they are having weak intermolecular forces. In fibers, they have strong intermolecular forces. So this thermoplastics, they are having the intermolecular forces are in between. So they are intermediate. Okay. So they are having intermediate or they are having in between forces. Means what? They are neither strong, neither weak. Okay. They are having intermediate. So they have intermolecular forces in between those of elastomers and fibers. So this thermoplastic polymer is one which softens on heating and becomes hard on cooling. So what happens? So this thermoplastic, okay, this softens. Okay, when you heat it, it gets soft. It softens and it becomes hard when you cool it. Okay, so what is the example? So the example is polyethylene. Okay, polyethylene, then polypropylene, polystyrene, etc. So these are some of the examples. So the intermolecular forces, what you need to remember, so intermolecular forces are in between that of elastomers and fibers. Okay, they on heating, it softens and becomes cool on hard, becomes hard on cooling. Okay. So next is what? Thermosetting. So next is what? Thermosetting polymers. Okay. Thermosetting polymers are what? So these are cross-linked. So you know what do you mean by cross-linked now? So these are cross-linked and heavily branched. Okay, so these are cross-linked and also heavily branched molecules which on heating they undergo cross-linking. So on heating it undergoes cross-linking. Okay. So it becomes hard. So they do not soften on heating. So what happens when you heat it? Okay, when you heat it, it do not get softened, but becomes hard on heating. Okay. When you so as in this case in thermoplastic, if you heat it, it becomes soft. Okay, and on cooling it becomes hard. But in this case of thermosetting polymers, okay, in this type of thermosetting polymers, they do not soften on heating but becomes hard on heating. Okay, so it forms a so it becomes hard, or it is a insoluble mass, so it is having some insoluble mass. Okay, what so these polymers, they cannot be reused. Okay, they cannot be reused. So these polymers, they cannot be reused, thermosetting polymers. Example is what? Bakelite, then urea, formaldehyde, polymer, etc. So this is the examples for thermosetting polymers. So we'll see some of the important polymers. Okay, we'll see some of the important polymers. What are the monomers present and what is the type of polymer? Okay, whether it is addition polymer or it is a condensation polymer. Okay, so first is polythene. Okay, polythene, it is made up of a monomer called ethene. So it is made up of a monomer called ethene. What is a type of polymer? It is a addition polymer. So small unit of repeating units of ethene, they add up to give you polythene. Okay, then polypropylene. Okay, polypropylene. So what is the monomer? Monomer is propene. So it also adds up to give you. So it is a addition polymer. Okay. So next is Teflon or PTFE. Okay, so this is what? Teflon. Okay, so so CF2, okay, so tetrafluoroethene, so this is tetrafluoroethene. So tetrafluoroethene, so this is a monomer which is present. So when this small units of tetrafluoroethene, what happens? Tetrafluoroethene, when you are repeating it, so it forms polytetrafluoroethene. Okay, so what type of polymer it is? Chain growth homopolymer. Homopolymer means what? Only one type of repeating unit is there. So it is a chain growth. So it is a chain growth homopolymer. So one type of monomer only adds up to give you a chain growth homopolymer. So next is what? Polyacrylonitrile. Okay, so next is what? Polyacrylonitrile, or it is called as Orlon, or it is called as Orlon. Okay, polyacrylonitrile. Okay, so polyacrylonitrile, or the other name is Orlon. So what is the monomer? It is acrylonitrile. Okay, so this is the structure, acrylonitrile. So this is the structure. So what type of polymer it is? It is addition homopolymer. So it is made up of this acrylonitrile itself. So next we'll see polyvinyl chloride. So it is abbreviated as PVC. Okay, it is abbreviated as PVC. What is a monomer? It is vinyl chloride. Okay, it is vinyl chloride is the monomer. And what is the type of polymer? It is chain growth homopolymer. Why it is chain growth homopolymer? Because it is made up of only one unit. So it is vinyl chloride. So vinyl chloride adds up to give you a chain growth homopolymer. Then polystyrene. Okay, polystyrene, what is a monomer? It is styrene. So this is a structure of styrene. So what type of polymer it is? It is addition homopolymer. Okay, what it is? It is a addition homopolymer. Then next is polymethyl methacrylate. Okay, PMMA, abbreviated as PMMA, polymethyl methacrylate. Okay, so the structure of what is the monomer? It is methyl methacrylate. Okay, so this is the structure of monomer, or this is methyl methacrylate. Okay, so what is the type of polymer? It is addition homopolymer. Okay, it is a addition homopolymer. So next we'll see natural rubber. So what is the natural rubber? It is isoprene. Okay, it is isoprene. So natural rubber, this is isoprene. Monomer unit is isoprene. It is isoprene. What is the IUPAC name? It is 2-methyl-1,3-diene. Okay, 2-methyl-1,3-diene, or it is cis-1,4-polyisoprene. Okay, or cis-1,4-polyisoprene. What do you mean by cis? So either side of the double bond, you have same atoms. Okay, you have same atoms attached to the either side of the group. Okay, so it is isoprene. Okay, isoprene. So what is the type of polymer? It is a additional homopolymer. So what do you mean by vulcanization of rubber? So we had what is vulcanization of rubber? So you are heating this natural rubber. Okay, you are heating this natural rubber with 3 to 5% of sulfur at a temperature of 373 to 415 Kelvin. So this on vulcanization. So what you do, natural rubber, you are heating it with 3 to 5% of sulfur at 373 to 415 Kelvin. Okay, so this on vulcanization, sulfur forms cross-linked at reactive site. So in this natural polymer, they form a cross link. Okay, they get at the reactive side of this double bonds. Okay, and because of this, when you heat it with sulfur, the rubber gets stiffened. Okay, it gets hard. So this is about vulcanization of rubber. So next we'll go to neoprene. Okay, neoprene is called neoprene is nothing but vulcanization of rubber. So it is an artificial rubber. Okay, it is a synthetic rubber. So this is an example. Neoprene is a synthetic rubber. Okay, or it is called as what? Artificial rubber. Okay, so monomer is what? Chloroprene. Okay, it is chloroprene. So this is a monomer unit. Then type of polymer, it is a addition homopolymer. It is what? It is a addition homopolymer. So next is what? Buna S. Okay, Buna S is made up of butadiene and styrene. Okay, butadiene and styrene. So you can see the monomer 1,3-butadiene plus styrene. So what is the type of polymer? It is addition copolymer. What do you mean by copolymer? Two different, you can see there are two different monomer units. So when there are two different monomer unit, two or more, then it is said to be copolymer. So in this case, there are two different monomer unit. Next is Buna N. Buna N is called as nitrile rubber. What is a monomer? 1,3-butadiene and acrylonitrile. So you need to remember all the monomers. Okay, whichever polymers is there, you have to remember the monomers. Next is what? What type of polymer it is? It is the addition copolymer. Okay. Next, nylon 6,6. Nylon 6 is a type of polyamide. Okay, because there is a amide linkage. Okay, so there is a amide linkage. So it is a nylon 6 it is an example of polyamide. So what are the monomer units? Hexamethylene diamine and adipic acid. Okay, hexamethylene diamine and adipic acid. So type of polymer is copolymer. Okay, it undergoes a condensation reaction. It undergoes a condensation reaction with the elimination of water molecule. Okay, copolymer because there are two different monomer unit and it undergoes a condensation reaction. Okay, next is terylene or dacron. So it is a polyester. Why it is polyester? It is an example of polyester because they have a ester linkage. They have a ester linkage. So you can see ethylene glycol, right? ethylene glycol plus benzene 1,4-dicarboxylic acid, or the other name is terephthalic acid. Okay, so what are the monomers? Ethylene glycol and terephthalic acid. Okay, so with the it undergoes a copolymer condensation. So there are two different units, so it is called as copolymer condensation reaction. Okay, so when they add up, it undergoes a condensation polymerization with the elimination of water molecule. So this is an example of polyester, that is terylene or decron. So remember the monomer unit. So very important. Okay, so next, polymer is polyhydroxybutyrate. Okay, polyhydroxybutyrate, PHB. Okay, it is PHB. What is a monomer unit? It is 3-hydroxybutanoic acid. Okay, it is 3-hydroxybutanoic acid. What is the type of polymer? It is condensation homopolymer. Okay, it is condensation homopolymer. Next is urea formaldehyde resin. Okay, urea formaldehyde resin. The monomer unit is formaldehyde and urea. Okay, formaldehyde and urea. What is the type of polymer? It is copolymer. Okay, it is copolymer. Then next is bakelite. Next is bakelite. What is the monomer unit? It is formaldehyde plus phenol. So formaldehyde and phenol, when they add up, okay, so they form bakelite. So these are the two monomer unit. So what is a type of polymer? It is step growth thermosetting polymer. Okay, it is a step growth thermosetting polymer. Next is glyptol. Okay, next is glyptyl. So that is a monomer unit is what? It is ethylene glycol and phthalic acid. What is a monomer unit? Ethylene glycol phthalic acid. So what is the type of polymer? It is thermoplastic copolymer. Okay, so you need to remember here the polymer. Okay, whichever polymer you have to remember is monomer and the type of polymer. Very important. Okay. So next is nylon 6. So nylon 6 is made up of caprolactam. Okay, caprolactam. So what is the type of polymer? It is homopolymer. It is homopolymer. Next is polyhydroxyl butyrate co-hydroxyvalerate. Okay, so this is PHBV. PHBV is what? Polyhydroxyl butyrate co-hydroxyvalerate. Okay, so this is PHBV. So these are biodegradable polymers. So this is an example of what? Biodegradable polymers. Okay. So what is the monomer unit? It is 3-hydroxybutanoic acid plus 3-hydroxypentanoic acid. Okay, remember the monomer unit. So 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. Then what is the type of polymer? It is a condensation copolymer. Okay, it undergoes a condensation polymerization. Okay, so so these are a condensation polymerization. Okay, so next is we'll solve some of the question now based on this. Okay, so nylon threads are made up of. Yes, so how are this nylon thread made up of? So what type of this is nylon? Just now we had discussed this. Yes. So we had discussed it is a Lohit Kumar. Yes, it is a correct answer. It is polyamide polymer. Okay, it is a polyamide polymer. Yes, not D, not polyester. It is polyamide. Okay, polyamide. Yes, you can see here nylon 66. Yes, you can see here nylon 66, nylon 6, right? It is a polyamide. Nylon 66 and nylon 6, it is a example of polyamide. Terylene and decron, it is an example of polyester. Okay, not D, not D, it is a A. So see here, what is the correct answer? It is A. So it is A. Okay, polyamide polymer. Right? So nylon threads are made up of polyamide polymer. So we'll go for the next one. Bakelite is obtained from phenol by reacting with. Yes. How is bakelite? So what are the monomer units of bakelite? Yes. What is the? Yes, it is A. Correct. Good. Asha, Amrita, Kumar. Yes, it is correct. Okay, it is A. So you need to remember. So like these questions are asked, you need to remember the monomers of each. Okay, each polymer. So bakelite, how it is prepared? So it is prepared on reacting the phenol with your formaldehyde. Okay, correct. Good. So many have answered yes. Shilpa, yes. Everyone, yes, correct. So we'll go for the next one. Which one is classified as a condensation polymer? Condensation polymer means what? When two monomers, okay, they undergo condensation with elimination of small molecules. Okay. So see neoprene. Okay, neoprene, it is made up of isoprene itself. Okay, isoprene. So there is only one monomer unit. Isoprene undergoes repeating unit. So not B, not B. Then Teflon. Teflon is made up of what? Tetrafluoroethene, right? Tetrafluoroethene. So it is made up of tetra. It is CF2 double bond CF2. So not this also. Okay. Then acrylonitrile, acrylonitrile, polyacrylonitrile, right? So acrylonitrile, this is also a homopolymer. Okay. So it is made up of only one repeating unit. So this is also wrong. So it is A. Yes. Shilpa Naik. Yes, it is correct. So A is the correct answer. Yes. Okay. So A is the correct answer. Okay. It is Decron. So Dacron, here, Dacron, it is made up of what? Ethylene glycol and benzene or terephthalic acid. Okay, ethylene glycol and terephthalic acid, and it undergoes what? It undergoes a copolymer condensation, right? So we'll go for the next questions. Yes, next question. The polymer containing strong intermolecular forces. Example, hydrogen bonding is. Yes, it is nylon 66. Okay. It is nylon 66. So the correct answer is A. Yes. Many have answered it A. Yes. Amruta, Saundarya, Tarun. Yes. It is A. Okay. So we'll go for the next one. The catalyst used in Ziegler-Natta process for polythene manufacture. Okay. So which is the Ziegler-Natta catalyst? What is the composition of Ziegler-Natta catalyst? Very important. Ziegler-Natta catalyst, you need to remember the formula as well as the chemical formula as well as your this. Okay. Then what it consists of. Yes. So Ziegler-Natta catalyst. Okay. So it is made up of triethyl aluminum. So it is made up of, yes, A. Yes. Many Rakshita, Shilpa. Yes. Okay. So it is Pavitra. Yes. It is A. It consists of triethyl. So, and titanium tetrachloride. So it is TiCl4 plus C2H5 thrice, okay, aluminum. So this is the complex of Ziegler-Natta. So this is a composition of Ziegler-Natta. So it is used for preparing your high density polythene. Okay, it is used to prepare the high density polythene. So we'll go for the next one. Nylon 66 is not a. Nylon 66 is not a. So you know it is a example of polyamide. Okay. So it is correct. Then it undergoes a condensation polymer, correct. It is a copolymer, correct. So it is this, okay. It is homopolymer. It is not a homopolymer. Okay, right. Yes, Rakshita, Shilpa, Pavitra. Okay. Then again, who has answered? Kumar. Kumar A, no. It is D. Okay. Yes, Sujata Amruta, correct. Okay. So it is what? It is D. Homopolymer is, it is not a homopolymer. Okay. So rest all are correct. So homopolymer. So it is not a homopolymer. So it is a condensation polymer. It is a type of polyamide and it is a copolymer. Okay, correct. So we will go for the next one. The monomers of Buna S rubber are. Yes, what are the monomers of Buna S? Buna S. Buna is what? Buna is what? Butadiene. Okay, so one is butadiene. So another is what? Yes, Lohit Kumar, correct. Others? No. Rakshita, it is correct. Sinchana, yes. Yes, so it is A. Okay, it is Pavitra. Yes, it is correct. So it is what? Buna S. Okay, S. So remember, Buna S is what? Butadiene and S is styrene. Okay. Buna, yes. Okay, Buna S is styrene and butadiene. Okay, so this is the correct answer. Terylene is not a. Terylene is not a. Polyester fiber, step growth polymer, chain growth polymer, copolymer, what? It is not a what? Yes, Amruta, Lohit, Pallavi, yes, it is not a chain growth polymer. Okay, Terylene is actually a copolymer. Okay, it is a copolymer, so it undergoes what? It undergoes a step growth polymerization. So it undergoes a step growth polymer. So it is made up of what? It is made up of ethylene glycol and terephthalic acid. Terylene other name is what? Decron, right? So it is D. Yes, Pavitra, Ramesh. Okay, many have answered it right. Okay, Malik. Yeah, yes. Okay, so everyone, it is D is the correct answer. Okay, so we'll go for the next one. So D is the correct answer. So next is which one of the following is an addition polymers? Yes, which one of the following is addition polymers? Yes, Pallavi. Yes. Yes, Soundarya Kumar. Yes, it is C. Okay. Yes, it is C. It is C. Why it is C? Why it is C? Neoprene. Okay, neoprene. It is an addition polymer of what? What is a monomer? It is chloroprene. Okay, so chloroprene. It is so it is a monomer. So which repeats. Okay, which repeats to give you neoprene. So it is an addition polymer. So this is example of addition polymer. Correct. Okay, so we'll go for the next one. So which one of the following is a biodegradable polymer? Yes, which is one of the following is a biodegradable polymer? So this biodegradable, it can be degraded by microorganism. Yes, Lohit Kumar, yes. Then polyvinyl chloride, no. Yes, Gahan, Soundarya, wrong, no. No. Yes, Amruta, right. Rakshita, yes. So it is what? It is A. Okay, cellulose. So cellulose is what? It is obtained from nature. So nature, so it can be easily degradable by microorganism. Biodegradable. So easily it can be degradable. Okay, so it is cellulose. So cellulose is the correct answer. So we'll go for the next one. Three-dimensional molecules with cross-linked are formed in the case of. So in which cross-linking takes place? Yes, thermoplastic, thermosetting plastic, both or none? Yes, we have discussed this. Yes. Amrita, Gahana, Kumar, not Kumar. Yes, Pavitra. Yes, Sandhya, correct. It is what? It is thermo, wait. So it is what? Thermo setting, right? So it is example of thermo setting plastic. Okay, it is example of thermo setting plastic. So we'll go for the next one. So raw material of nylon 6 is, okay, which is the raw material of nylon 6? means which is the monomer. Yes, Gahana, correct. Then yes, Rakshita, it is right. Then yes, Lohit Kumar. Then Kirti, yes, it is D. Okay, so many have answered it D. Yes, good. Okay, so it is D. D is the correct answer. It is what? Caprolactam. Okay, it is caprolactam. Okay, caprolactam, it is a raw material which is used to synthesize your nylon 6. Okay. So the synthetic polymer which resembles natural rubber is, yes, which resembles the natural rubber is. Synthetic number example, yes, neoprene. Yes, many have answered it correct. Okay, good. So neoprene is the correct answer. So I hope everybody has understood this. Okay. So what is important here is you need to remember the monomer units. Okay, you need to remember the monomer units. What is the type of polymerization? Okay, so based on that, you can solve any type of question from this. Okay, so we'll solve some extra questions. Just a second. Yes. Okay. So which of the following is a copolymer? Okay, so which of the following is a copolymer now? What do you mean by copolymer? You know. Now you know what are the monomers also. Okay. So you need to answer now. Yes, Rakshita, it is right answer. Geeta, yes. So copolymer means what? It is made up of two different monomers. Pavitra, Saundarya, yes, it is B. Okay. So it is B. B is the right answer. B. So polythene made up of ethene. Polyvinyl chloride, okay, PVC, polyvinyl chloride made up of what? Only one unit, that is vinyl chloride. Polyacrylonitrile made up of only one unit, that is it is made up of acrylonitrile. Okay. So bakelite is what? Bakelite is made up of phenol. Okay, and formaldehyde. So what is the wrong? Which one is for example of copolymer? It is what? Bakelite. Okay. So B. B is the right answer. So we'll go for the next one. Polymers are not classified on the basis of which of the following, right? We saw on the base of sources. We saw the method of preparation. Okay, how it is prepared. That is, it is undergoing addition, condensation. Based on structure also we have seen. It is linear, branch, cross-link. Did we see based on number of monomers? No. So the correct answer is what? B, right? So B is the correct answer. So number of monomers, it does not depend upon number of monomers. Okay. So it is poly, right? Poly means what? More. So it is n number. Large molecules are formed by n number. Yes, many have answered it correct. It is B. Next is which of the following types of polymers is not based on the classification by the source? Yes, which are the, so you know what are the types of polymers based on the source? Yes. Yes, elastomers, right? Correct. Yes, Gita, Sinchana, Pavitra, Saundarya, Amrita, Ramya. Yes, many have answered it right. Good. So it is elastomers. So these are natural, semi-synthetic, synthetic. It is a classification by source. Okay, good. So we'll go for the next one. Which of the following is not a natural polymers? How do you obtain natural polymer from plants and animal? Okay, the origin is plants and animals. So here, which is not an natural polymer? Yes, Tarun, Hema, Malik. Yes. Okay. So it is rayon. Okay, rayon is a synthetic material, right? So it is a uh, so starch, cellulose, RNA, it is all natural polymers. So rayon is not. Okay. So A is the correct answer. All macromolecules are polymers. Is it true or false? All macromolecules are polymers. Yes. So it is true. Basavraj, Hema, yes, it is true. Correct. Good. Vinayak, yes. Okay, many have answered it right. Good. Okay. So we'll go for the next one. The synthesis of which of the following polymers involve the repeated loss of small molecules? Yes. In which synthesis polythene is made up of ethene? So no. Next is Buna S. Buna S, Buna N. No. Then it is what? It is D, right? D is the correct answer. Nylon 66. It undergoes what? It undergoes a condensation reaction with condensation polymerization with elimination of water molecules. Okay, so you need to remember which are the monomers. So based on that, you have to answer it. So the compound CH2, CH6H5N is a, what is it? Is it a homopolymer? It is a copolymer, condensation polymer, network polymer, what? It is a homopolymer. Yes, Geeta, right? Malik, yes. Kumar, Pavitra, yes. Good. Okay. So it is a homopolymer. It is what? It is styrene. Okay, this is styrene. This is the compound name is styrene. So it is made. So it is polystyrene. So this is polystyrene. So what is the this monomer here is? It is styrene. So styrene, when it is so monomer, so that it is only one monomer involved, so it is a homopolymer. Which of the following is not a elastomer? Yes, what is which is not a elastomer? Yes, PVC. Okay. So here you know what are elastomers. Elastomers are having very weak intermolecular forces, right? And these are very elastic in nature. Okay, when you stretch it, okay, when you stretch it, again it will come back to its original position. Okay. So this is which is PVC. If you can plastic, you can PVC pipes, can you stretch them? No. Okay, so this PVC is a plastic and not a elastomer. Okay, so the correct answer is what? It is C. The polymer shown is, so this is a polymer. So it is a what? Polymer shown is a elastomer, fiber, thermoplastic, thermosetting plastic, what? Yes, good. Yes. Okay, it is a C. It is, the answer is C. Okay, the answer is C. The answer is C. Okay, the answer is C. It is a thermoplastic. Okay, it is a thermoplastic. Neoprene, right? Neoprene. So it is a thermoplastic. Next. So next is dash undergoes permanent deformation on heating. Dash undergoes permanent deformation on heating. Yes, Rakshita, Lohit Kumar, Geeta. Okay, so it is D. Okay, it is bakelite. Remember? Okay, it is a bakelite. The answer is bakelite. So bakelite undergoes permanent deformation on heating. Terylene. Okay, terylene is a thermoplastic polymer prepared from addition polymerization. It is true or false? True or false? Yes, it is false. Yes, correct. Okay, it is false. Yes, many have answered it right. It is B, false, because it is obtained by condensation polymerization of what? Ethylene glycol and terephthalic acid. Okay, it is not formed. It is a thermoplastic polymer. It is correct. It is a thermoplastic polymer, but how it is prepared? It is obtained by condensation, polymerization of ethylene glycol and terephthalic acid. Addition polymerization is also known as, what is addition polymerization called as? Yes, Kumar, Tarun, Malik, Sinchana, Pavitra, Shilpa. Yes, good. Many have answered it right. So it is chain growth polymerization. So it is called as what? Chain growth polymerization. Next, which of the following cannot undergo addition polymerization? Yes, which of the following cannot go addition polymerization? See at the options. Yes, ethane. Yes, Rakshita, Lohit. Yes, it is ethane. Ethene, propene. Okay. Then vinyl benzene. So it is. These are the example. These can undergo polymerization. Ethane does not have any double bond, so it does not undergo polymerization. Okay. So we'll go for the next one. Which of the following is not a type of addition polymerization? Yes, many have answered it right. It is B. Okay, it is B. Addition polymerization is further classified into what? It undergoes via free radical polymerization. So it can go undergo by free radical polymerization. Radicals can get polarized. Okay, polymerized or anionic cation, anionic or cation. Okay, so these are three types of addition polymerization. So for addition polymerization, further are classified into free radical polymerization, anionic polymerization, and cationic polymerization. So polycondensation polymerization is not a type of addition polymerization. So we'll go for the next one. Which of the following is not a suitable initiator for free radical polymerization, addition polymerization reaction? Yes. Yes. Rakshita, Geeta, Malik, Shilpa, Lohit, Kumar. Yes. Nuhu. Yes. So good. Many are answering right. Okay. So very good. So the answer is D. Benzoquinone. Okay, benzoquinone. So So you know, for free radical, okay, for undergoing a free radical polymerization, so we need to use a suitable initiator, and for to do a polymerization by free radical mechanism, you require a peroxide. Okay, so I always free radical polymerization, okay, it undergoes in the presence of peroxide. So these are all examples, or these are good initiators. So benzoquinone is not a initiator. It is not suitable initiator. Next, which of the following is the non-biodegradable polymer? Non-biodegradable polymer. We had discussed this. Non-biodegradable polymer. Not C. C is low density polyethylene. No. Non-biodegradable polymer, there are two examples. One is nylon 2, nylon 6, and another is PHBV. Okay, PHBV. So the answer is D. Yes, Busavraj, Nuhu. Okay, many have answered. Gita. Okay, so it is wait. So it is D. Okay, it is D. D is the correct answer. PHBV. So identify the biodegradable polymer from the following. So which is the biodegradable polymer from the following? Yes, Pasavraj, it is right. Okay, it is C. C is the correct answer. Yes, Sinchana, Shilpa, right. Good. So it is polystyrene. Okay, polystyrene is example of biodegradable polymer. Next, what are the monomers of PHBV? Which is the monomers of PHBV? No, not C. I discussed this. I had told you about it. Yes, Amrita. Yes, Amrita has given the right answer. Yes. So it is D. Okay, D is the correct answer. Okay. 3-hydroxy-butanoic acid, 3-hydroxy-pentanoic acid. Okay, so it is correct answer is D. Nylon 2, nylon 6 is a biodegradable polymer. True or false? Yes, it is true. It is a which of the following is used in the making of unbreakable cups? Yes, it is A, urea formaldehyde. Okay, urea formaldehyde. Good. Okay, so we'll go for the next one. What is the polymer obtained from the condensation of? So this is hexamethylene diamine and adipic acid. So what is the answer? A. Yes, many have answered it right. Yes, A. Right? A. Nylon 66. So we'll go for the next one. Cyclohexanone on treatment with hydroxylamine gives P, which on treatment with sulfuric acid gives Q. When Q is heated with water at high temperature, R is obtained. So you have to identify the R. What is R? Yes, it is A. Okay, good. It is A. So I'll tell you the reaction, how it goes. So this is your cyclohexanone. Cyclohexanone. It will be treated with what? Hydroxyl. Okay, hydroxylamine. So this will form. So with the loss of water molecule. So this on hydrolysis will give you okay. So this is what? Nylon 6. Right. So this is nylon 6. So A is the correct answer. Okay. Next, glyptal is obtained from the condensation polymerization of ethylene glycol with. Yes. Yes. Saundarya, Amrita. Yes. Good. It is with terephthalic. It is with. Yes. Terephthalic acid. No. It is not glyptal. Glyptal. We are talking about glyptal with phthalic acid. Okay. It is with phthalic acid. So glyptol. It is obtained from the condensation polymerization of ethylene glycol with phthalic acid. Okay. So next. Which of the following is not required for production of dacron? What is not required? So the temperature required is correct. Okay, this is the temperature, correct temperature required. So ethylene glycol also is one of the unit. Terephthalic acid is also one of the unit. Monomer unit, correct. So the answer is D. So where this triethyl aluminum titanium tetrachloride is used, can anyone tell me? Yes, you can message in the chat box where triethyl, what it is called? Triethyl aluminum titanium tetrachloride, what it is called and where it is used. Yes, triethyl aluminum titanium tetrachloride. What it is called as? What is the name? So it is what? It is, yes, Shilpa Nayak. Yes, it is correct. It is Ziegler-Natta catalyst. Good. Okay. So it is used in preparation of what? It is used in preparation of high density polyethylene. Yes, many. Yes, Tarun, Lohit. Yes, good. Okay. Yes, very good. So we'll go for the next one. So bakelite is a cross-linked polymer. Bakelite is a cross-linked polymer. True or false? Yes. Yes, correct. Okay, Shilpa, right. It is true because it is made up of phenol and formaldehyde. Good. Last two questions are there. We'll solve it. Which of the following is a monomer of natural rubber? Which is a monomer? Yes, Shilpa. Yes, it is isoprene. Okay, isoprene. Many have answered it right. It is isoprene. Okay, so B is the correct answer, isoprene. Next, Buna N involves acrylonitrile as one of the monomers. It is true. It is true. Okay, it is true. It is true. So Buna is acrylonitrile plus your butadiene. Okay, Buna N. Buna S is what? Buna S is butadiene and styrene. Okay, so these are some of the questions which we have solved for today. So if you get some more questions, try solving on polymers. Okay, so I hope you have understood today's session. Okay, so we'll meet in the next class. Okay, thank you. Have a nice day.